Patty Simpson with Simpson Math. In this video, we're going to look at synthetic division and how we can use it to help us factor a polynomial. So first, let's just talk a little bit about division and factoring. Here, I have 12 divided by 3 equals 4. We call this 12 the dividend, the 3 the divisor, and the 4 the quotient. Because 3 goes into 12 evenly with no remainder, we say that 3 and 4 are factors of 12. So the fact that there is no remainder is part of that, what makes them factors of 12. And then also notice that when we do that division, we have 3 times 4, our divisor, times our quotient equals that dividend. These two factors can multiply together to make that product. We're going to use that idea to help us with polynomials to factor them. So here we have a polynomial and we want to find the factors of this polynomial. In the past, what we've done is we first look for a greatest common factor. There is no greatest common factor here, or the greatest common factor is just 1. So then, since there are 4 terms, we attempt to group it. We take the first 2 and we group those together, and we look for a common factor just within those 2. In that 2, there's an x squared in both of them. So I'm going to factor out an x squared, and it leaves me with x minus 6. Then I'm going to look at those back 2 terms, and I'm going to factor those. And the greatest common factor in there is just a -1. It has that leading negative we're going to take out. And then the greatest common factor is just 1. And again, then I'm going to see what I'm left with. Well, that leaves me with an x minus 30. When we do grouping, we want these 2 to match so we can factor them out. And look, they don't match. We've been leading up to this so that when they don't match, we can't use grouping and we all cry. It'll be okay though. Let me walk you through it. So instead of grouping, what we're going to do is use the synthetic division to help us find a factor. So we're going to synthetically divide this polynomial by a binomial to help us to find the factor. I'm going to take this polynomial and I'm going to divide it by, well, I have this magic hat that I'm going to pull out a factor out of, and we're going to divide it by x minus 3. So that's the binomial we're going to use to divide it. We're going to divide by x minus 3. Let's see if x minus 3 is a factor. If x minus 3 goes into this polynomial evenly with no remainder, then we will know that x minus 3 is a factor. Remember with synthetic division that we change this sign from subtraction to addition. From whatever the sign is, we change that so that we don't have to subtract throughout our division. Remember when we did long division, we had to subtract each time. But because we changed the sign here, we're not going to have to do any subtraction. Then I'm going to write down my coefficients of my polynomial: 1, -6, -1, and 30. So here I have my polynomial. I'm dividing by that x minus 3. With synthetic division, we drop down this first number. Then, diagonally, we multiply. Just if we're doing long division, we would multiply. Here we've got 3 times 1, which gives me 3. Then, normally we would subtract in long division, but because we've already changed that sign, we're going to add these. So -6 plus 3 gives me a -3. So this direction, vertically, we're going to add. Then I'm going diagonally again, so I'm going to multiply. 3 times a -3 gives me a -9. Vertically, I add to get a -10. Diagonally, I multiply to get a negative 30, and vertically I add to get a 0. This last number in our synthetic division is our remainder. So here we have no remainder, which tells me that yes, x minus 3 is a factor of that polynomial. In fact, I could rewrite this. Remember, when you have synthetic division, your quotient is always 1 degree less than your dividend, so that you have x squared, and now I'm just going to count down, so x squared, x to the first power, x to the 0 power. So I could actually write this polynomial as 2 factors. My factors are x minus 3 times this quotient, x squared minus 3x minus 10. If I were to multiply this out, I would end up with that original polynomial. I can even factor this all the way down to its linear factors, so that all of them have a degree of 1. Here I already have it as a linear factor. Now I have 3 terms, so I can use my AC method to help me to factor this. Or because it is a quadratic, I could use the quadratic formula to help me to solve for x if x equals 0, and then use that to help me find those factors. But here, because it's 3 terms, let's use our AC method. Our A is 1, our C is a negative 10, our AC is a negative 10. The factors in negative 10 that add to a negative 3 are 5 and 2. One of them's got to be negative because this is negative, that's a negative. So negative 5 times a positive 2 makes a negative 10, and it adds to be that negative 3. So these factors, because A is 1, I can just jump straight to the factors, x minus 5 and x plus 2. So now I have factored this polynomial down to its linear factors. So we can use synthetic division to help us to see if a binomial is a factor of that polynomial. And then once we find a factor, it helps us then to factor it all the way completely down to its linear factors. Now, the question is, how did I know in my magic hat that x minus 3 was a factor? We're going to need to be able to discover our factors, and in the next video, the possible rational roots theorem helps us to create our own magic hat to help us to decide which factors we should use to test, to divide into our polynomial. This is going to help us completely as we graph our polynomials completely. Math Made Simple at Simpson Math. Thanks for watching.